back to our YouTube channel Code with Honey. Today we are going to solve LeetCode day 20th challenge, delete duplicate folders and system. So this is an extended hard version of the question which we solved yesterday. So if you haven't solved the yesterday's question, I highly recommend you to solve the yesterday's question. So if you are feeling having any trouble in solving, please do watch the approach, because approaches are used, what are the different approaches we have used to solve that yesterday's question. So yeah, that will be highly helpful to solve this today's question, because we'll be straight away going to the optimized approach, because without that optimized approach it will be very hard for to solve today's question. Okay, without any delay, let's take a look at the question description. So what they are telling, due to a bug, there are many duplicate folders in the file system. We are given a 2D array paths where paths of I is an array representing an absolute path to the ith folder of the file system, which means they have given I equals to the ith folder is Y. This is the whole folder structure for the file system. For example, 1, 2, 3, that represents the path 1, 2, 3. They'll be giving us an array instead of uh, we're giving a path with a slash. So there are two folders not necessarily on the same level or identical. If they contain the same non-empty sets or identical subfolders and underlying subfolder structure, the folders do not need to be at the root level to be identical. If two or more folders are identical, then mark the folders as well as their subfolders. Okay, for example, what they're saying. So for example, this Y we have here, which is under a root folder, right? Here if you see, this is under B folder. These should not be at the same root folder to be identical. Okay, that's what. Also it should not be at the same level. Here it is at the same level, AXY BXY at the same level. But if you assume slash A slash B C and XY BXY, still this XY is identical. Okay, what they are trying to say is folder structures are not necessarily on the same level or identical if they contain same non-empty set of identical subfolders. Yes, obviously XY is an identical subfolder. Before that, how many folders exist, that doesn't matter. If these two folders are having the same structure, that yeah, we have to mark them as identical. Okay, so I hope this makes clear. Here if you just take this example, A and B are thus identical because all the subfolders are same. See, AX, we have BX, we have AXY, AZ, so all under AX, AZ, BZ, everything, all the children are identical, so A and B are identical. So if assume if B slash W were included in this, so A and B were not identical, but still ZY and Z are identical, that should be removed. Okay, yeah. So note that AX B's would still be considered identical even with that added folder. That's what they are trying to say. Even if you added BW, now BX and AX would be identical because under that we have their Y, right? I hope this makes clear to you guys. Still, we'll just look into our examples, which will run through the example, which will give more clarity about this question. So, okay, now once all the identical folders and the subfolders have been marked, the file system should delete all of them. Okay, thus once we have deleted, we should have only folders that are not identical and that does not deleted. So return the 2D array containing the paths of the remaining folders. After deleting all the marked folders, thus paths may return in any order. Okay, there's no need of you have to return in the certain order. Yeah. So in this case, if you see, this is a root folder, A, C, D we have, and that A, B we have, C, D, C, B we have, D, A we have. So if you see, B is identical, A and C are identical because it contains the same. So we will be removing this and our answer will be D and D, A. Hope this clears. Next, the same will be taking over. Now see Y at the different level. So if you see L, A we have, C we have, AB we have, CD we have, W, Y, So we have root folder as well as the subfolder. So wwy, so abxy, abx we have. So if you see here, this y is at under identical folder, xy is identical, wy is identical. So we'll be having answer a, ab, c, cb. Hope this makes sense now. So here if you see a, b, c, d, so no one is identical, will be returning all the whole file systems. Hope this makes clear. Now just take a look at the uh, visual representation, how we are going to approach, how we are going to store, how we are going to retrieve all this. We'll just take a look. Okay, yeah. Now if you just see this, these are the examples that we are going to take to demonstrate how we are going to look into the how we are going to take a look at the approach. Okay, now if you see here, root ab cb we have, obviously we know this both are identical, right, because it has the subfolders common, right? So we want our results will be d and da. Okay, correct. Now for this, what will be our answer? If you just take a look, I already explained, we have these both are identical folders, so we'll have a b, c, cb. You can ask how come cb has the same folder, but internally we don't have the same, all the path is different, right? It is not identical. Still we have the same name, but internally we have so many. Identical will comes if a, c, b, x, y, all this internal folders also should contain the same, then only it is identical. Okay, I hope this makes sense to you. Okay, now what will be our answer? A b. So next c, c, b. That's it. Okay, here this is some bigger example that I took. So if you see this x as dt, this o as td, okay, then obviously these are identical. So this path we won't take, but so this has one identical folder, but not all those were identical. So still o will be there, ol will be there, same h will be there, ht will be there. Okay, then if you just, okay, now I'll just strike through that h. So this, so but o has another L as well, right? Yeah, so you can't, o has another children, so you can't remove that. Then we have b, and let's see this. Okay, another anything that is common, I don't think ol we have anywhere, we have L. No, this is lq, so we can have ht, we can have now c, right, b, c, f, we have f, r, we can have, then we can have f, o and f, o, l as well. Then l we have written L and LQ, F, R, G, C, R, we need one. So F, R, G, C as well. Okay, I hope we have written everything right. Yeah, so basically how, even if it is in a different order, if it is same children you can remove, but another children if it exists, for example ol we have, that is not similar, right? So still you can have o and ol, right? O and ol. I hope this makes sense how this structures works. Now just take a look at pseudocode. Okay, pseudocode, what we are going to do, obviously is like yesterday we are going to create a trie structure, right? Class trie we are going to take. So in this, to identify two structure is equal, which is very easier to compare. So will you check this children is equal, this children is equal, like this will, if you keep on checking by traversing, it will be having so much, we need to pass so much to find out, okay, this children and this children were equal, then you have to return back this, whether this parent and this is equal. All this is very hectic. But if you have just stored it in a string, okay, for whatever it is, whatever you passing, a b x y, if you store it in a string, okay, then obviously it will be very easy, right? C b w y. So if we are storing it in a string, it is very easy to for us to identify whether this two were equal or not. So that's why we are going to do serialization. For that, serialization is a technique where you can convert a node into a string and you can have it and you can compare. So I'm going to write for every node I'll be having a serial which is initially empty and the corresponding children, because it will be an array. Now we are going to create a string. Initially they ask, if you would have noticed, the input will be in an array, right? It will be a b, all this will be in array that we are going to create a trie structure like this, that I have explained earlier in yesterday's question in the start of the approach 3. You can just go and watch how we are going to create a trie structure from an array of values. Okay, this is the trie structure. In addition, yesterday we just will be appending a children. Now we need a serial to just compare the two values are equal. Okay, I hope this makes sense. Now we assume we have figured out, or we have created a trie structure already. Like this, we have a trie structure called children. So for the particular creation of the trie structure, I would have appended the code in yesterday's solution, as well as today's GitHub link will have the code how we are going to create a trie structure. Please go and have a look. Now I assume I have a trie structure which has children as well, like this. Okay, this is a children, as well as I will have a serial, two fields I will have. Now straight away I'm going, assuming that I have a trie structure. If you haven't watched, if you doesn't know how to create a trie structure, please go and check out yesterday's video how to create a trie structure from an array of values. Now we got class solution. So now what we are going to do, we are going to create a, from the trie structure we know we going to do serialization. How we will be going to do serialization? We want to know this a, this is the b, this is a's children is b, b's subfolder is x, x subfolder is y. So if to have, we have to compare, okay, these two have same structure, so this is identical. So we don't want the root folder. We should know first. We'll be finding out which are identical. For that we will be having a frequency, right? So we will be create a frequency which is nothing but counter. Okay, initially the counter will not have any values. Okay, so the frequency, let me have the frequency here. Okay, now what we will be doing, we'll be having this trie structure. So we have to call the root. We'll be having a function called construct, which means you are serializing. Okay, construct will give us a node. So if node doesn't have a children, then which means it's the end of the node we are returning. Okay, So else what we will be doing, we'll be having a empty array. Okay, in that empty array what we are going to do, we'll be traversing through each folder and their children. In this is a children is a dictionary, right? So that we can easily pass that node dot children of item which has key value. So now it will give key, folder is a key and the children will be our values, right? Like that we would have stored. Okay, so this A will be having a children, maybe I can write this try structure. A will be having a children B, which is so how the try structure will look like is A, I will be having a children called B. Again for B is a key, for this I will be having a children called X. Okay, X will have a children called Y, which is a empty dict. I hope this how this works. This is how the structure will have. So A is a, if A is a folder name and B is a children. Okay, folder comma child, you will again get a node only, which is a try node, correct? Okay, so now what we will be doing, we will be again call this construct function of the child, right? It will keep on going till this Y. Thus A node will call B, B node will call X, X will call Y. So all this will be going, right? So once it has gone, what we will be doing, we have to append a folder. Okay, once it has traversed first, at this point it Y would have gone to the next children, it would have written with empty. So what we would have doing is, we will be appending the folder which is the root plus their child serial. Okay, so that I am going to append with open and close, so that I will get the exact structure child dot serial. Serial would have created, right? Serial plus close. So which means at this point I will folder is Y plus I would have got empty, I don't have any children to that. So to identify each children, I'll be whatever for example A's children is B, that would have started with like this. So X children is Y, so Y has empty, so all like this it will be creating. So which means A is a children of B, B is a children of X, so that even we have some other structure. For example here A B X Y, okay, some other structure which has X B A Y, something like that. So to compare, what we will be doing initially, we would have sorting, right? To compare two strings we will have sorting. So if you don't append this open and close, okay, so if you sort, what will happen, both will become A B X Y, A B X Y, and it will return these both are true. But no, it is not true, because here A is a root folder for B X Y, here X is a root folder of B A Y, right? So if these both the root and its folders are same only, we will be doing. Okay, why we are still doing sorting, not for even after we are appending open and close, why do we need sorting in this case means, I'll just say why we need sorting here. So for this I have, for that only I have taken this example. Let's take here, so this X as DT, these both are children, this O as TD, these are children. So in this particular point what we would have got, let's assume O T and D, right? I'm not traversing from the root, I'm just traversing. Here X, D and T. It has both the children but in different orders. So it will return, if you want to sorting, what it will return? It will compare this two serials as not equal, right? So that's why we will be doing sorting to have, if it has more than two children, if it has more than one children, and if it is in a different order while we are creating a trie. Okay, this will have first children as T, this will have second children as D. Okay, for that only we are doing sorting. Okay, and why we are appending this? To identify whose subfolder it is. Okay, so yeah, I hope this makes sense. So once you have appended everything, what we'll be doing, we will be doing v dot sort. Okay, if it has more than one child, so it will be giving us in the same order, which is dt. Okay, yeah, so this dt now will have, now we'll be storing that particular dt in a frequency of, now we are okay, this is a particular node serial, right? Okay, for this y node, what is the serial, which is empty, but still what we are appending is, will be now updating the node dot serial as, we have to convert it into a string dot join v. Now we have converted into a string. Okay, now we will be appending it to a frequency counter, frequency of node dot serial plus or equals to 1. Okay, now because it's a counter will give us a defaulting. So now this y came. Okay, now it will have y like this, and this is sorted and it would have appended as y. So again, when we have traversed from w to y, okay, this is the node, when we have traversed to w to y, again we will get the same y and the count will get updated to 2. Okay, you guys, now it makes sense, right, how this works. Okay, now I'll be just updating the frequency folder. Okay, this is how we'll be creating the frequency. Initially we would have called this construct function with root. Initial root will be the trie structure. Okay, we would have a node called root. Okay, this is the root. Okay, now we'll just update all the frequencies, how it works. So here initially root will be, root would have gone, so root initially a comma b, again b would have gone, so b still has a children called x, so b comma x, so x just goes, x still has a child y, so construct child y will be going, y doesn't have any children, so what it will do, it will be creating, it would have written, so the folder is y, correct, y in children it will go, but it will return none, right? So now the folder is y, so y of like this it would have create. Now the this is what array of values, right? Y comma like this, y comma the child serial is none, so this will be our array. Now we are joining that array of y like this, so frequency of y we are updating to 1. So this is the frequency table, let's assume. Okay, now next, once y came, okay, the construct we have updated, right? Now the child serial, what is the child serial? Already y. What is the folder? X, correct, so x would have returned here, so x of y like this, we will create a node serial again. Now x of y will be updating to y. The same way, if once it is written, next b of x of y will be having the frequency of 1. So next a of b of x of y would have got updated to 1. I hope this frequency maps make sense to you guys. So next, once a comes, okay, this is the root folder, right? Here first we have traversed our a. Okay, next we will be traversing c will go to b. So b as doesn't have children, so b will create with b, so that frequency will be updating. B will be having 1, right? So I'll have another one. So b will have 1, then c of b will have 1. Next w comma folder is root, the child is w. Okay, w will go construct child. Now folder is nothing but empty. Initially the folder doesn't have anything, right? That root will have anything. So if you see w plus child serial, what is the child will go now? Y. So if you see y comma child and child node dot children is nothing but empty. So when y will go to the next child node dot children doesn't have anything, so it will return. Now again y will be formed again, but if you see frequency of y, we have already 1, so now it will get updated to 2. So like this only the same node values will be getting y. Now it is very easy for us to have the same node. Why we are doing this? It's very easy, right? So node dot serial will be, it is a string, so it is getting updated to 2. Now we know, okay, some folder with same identical exists. By frequency we got to know, right? Okay, now still we'll be adding again once it comes back. So w of y will be happening to 1. Okay, this is how the frequency table, how this is nothing but a DFS approach that we are doing. So in DFS we'll be having a node which is a constant n. So n log number of vertices we will be going. Here vertices we don't know, vertices is nothing but we'll be that too we won't traverse the same node again and again, but here it's not the case. We'll be traversing the same node even to have that log v comes, because if that path is traversed we won't traverse again, right? That's why log v will be taking. But here to calculate this df, anyway we'll be traversing through each and every, it's a DFS, but still we'll be traversing through all the road. Even though if it is same identical path, we will be still traversing through that. So which means we will be traversing, even though it's a DFS, and size of each word. So which is let's take L. Okay, size of L. So this much we will be traversing. Still we will be sorting in between, that will take log n, and also it will have stack space it will store. That is so I'm just telling for the construct function alone, the time complexity. Okay, the time complexity will be, again it will store the space, complexity will be stack. Again it is converting the node serial, right? Every time for at each root it is converting. So again that will be like n order of L, whatever that particular length, that time it will be converting that into a string, right? So yeah, so it to calculate absolute time complexity, it is very hard, but I'm just telling these all that we are doing for just for construct function alone. Space complexity, we are storing the same v every time, and we are storing it into a frequency the same n cross L. This might have n cross L plus storing will have order of L at any point, and plus stack space complexity. Okay, this is just for construct function I'm telling. Okay, now what we are going to do, now we are going to create now we are going to return the answer, what all the duplicates, how we will be going to delete the duplicate. So the same, we will be getting a node for operate. You just call a function called operate, which is passing you the root. Okay, so before this we will have two variables, right? What are the variable name we can give? So we can give we have a frequency, now we have a trie structure. Okay, we have a trie structure, we have a frequency. Now based on this frequency which is greater than 2, just don't add those root to the path. That's what we are going to do. Okay, so that's what this operate function is going to do now. So we'll have a folder called non-duplicate folders. That is the variable that we are going to store. Okay, non-duplicate folders, and we'll have a path which will store all the, so now in which will have all the path which is not identical. Okay, so here we have a, we are passing the root. Okay, now even though we have a straight structure, we have to, if it is a b is not identical, you have to add a once and b once. So when will you add this b? Once you got to know that it is not identical and this b serial is not same, then only you can append this root is not what, the b serial is not identical, and still if some path exists, okay, then okay, we know the root still has some path, either that is not identical or it has some other children. Correct? Okay, so those are the two cases. So let me explain clearly those two cases where we will be appending this path. Once we come to know that their children serial is not identical, which means based on the frequency we'll know. Okay, for example, you came to till this point. Okay, you would have added a b. To add a b x to the answer, before adding x, you will go to the its children and you will check whether this is identical to anything. If yes, we won't append this path. That's what we are going to do. How we will be going to do that, let's see. So first, frequency of node dot serial. Okay, at first itself we know which is greater than 1. Okay, this abxy itself has some other, okay, this a itself has some identical serial. So each for example, this root will have abxy. For example, ab of xy will be has more than 2, which means the same it has another. Then why we need to append any of the roots? No, right? We will not append it, so we'll be straight away returning. So we have 0 duplicate folders at the first, but here in our case it's not, we don't have anything like that. So what we are going to do next, so I have a path which is empty. If path has anything, then which means I will be appending it to a non-duplicate folders. So initially my path is empty, dot append whatever the path till now I have, those all non-duplicate folders. Okay, then the same we will be traversing folder and child in each node dot children dot items we will be traversing. So I am appending paths dot append. Now only I am appending the root folder. Okay, once I append the root folder, okay, for this root, okay, this root doesn't have any operate root, right? Operate root will go will be giving us the root so the root dot serial will be having empty because we wouldn't have passed anything, because at any point we would any first thing we would have passed through our children dot items. Okay, so node dot children dot item itself will go to the a, right, a c w. So initially folder will be a and their children will be b, whatever those a's children. Okay, initially folder dot append will be appending, we will be appending that a path dot append, and we will be calling this operate child. So next I'm passing that my child, which is b. For this only I have one child. For some cases we will have so many child, right? So if you see for this f, we have r, we have o. So once you have done, you are calling this operate b, which will go. Now once we have found this b is not b serial is not, frequency is not greater than 1. Okay, so if you see, is it greater than 1, frequency of node dot serial of b will be this only, right? So b of x y, so it is not greater than 1. So then what we will be doing, then only we will be appending its path a. Okay, then okay, if path and non-duplicate folders, yeah, I am just appending a. Then once you done for the one layer, okay, this doesn't have duplicate, only we are appending its root. Okay, if it has, then obviously we won't append its a. So then we'll be passing through the another child. So once you have operated one child, again you will be popping out from that. So yeah, we will be popping out after that, so that when you are traversing through the next shell, you should not keep on appending another a something like that. So I hope this makes sense. So now why we are doing popping out, then when you are going again, now a would have got appended. Next for b is the folder key for that what so now we will be getting x. Okay, now initially this is b, node dot children is b, so b is a key and x is a child. Okay, so now we will be checking whether that, I'm somewhat getting confused, just for a second. So this is the, we got the frequency, right? So now we will be traversing through, we will be calling this operate of root, which is nothing but this. Now this operate root dot children dot items has a c w, right? So acw, which means those children items only we will be traversing. So initially a, and those child will be all this objects. So this is the items, these are the children dot items. So for a we will be having this, so we will be appending a and we will be calling operate b. So we will be checking this b node serial is greater than or equals to 1. So b node serial, which is, so we will be checking the whether this b x y has more than one frequency. No, which means you can append a. So once you check the child node serial is greater than 1, we will be appending its root. So this is a. Okay, now our non-duplicate folder will have a. Okay, next, so next for For this we have B as a folder name, we will have xy B, and this is the only one child we have. So now I have appended A B to my path. Now again I'll be calling the node serial of A B is anything is same. So if for that, if you see x of y which has the same frequency, so now I'll be calling this, no it will not, so now I'll be appending B as well. Okay, so now we have appended AB, but now when you're going now, node.children.item is nothing but folder will be x, their children is y, so now you append x, correct. If you are going to operate child, now it will have this node serial which is okay, it has a frequency greater than 1, so frequency of node is y, right. This will be going child as y greater than 1, so you should not append its parent, so we won't come here, we'll be straight away returning, we'll be popping out. So this x is basically didn't get added to the array. Okay, then from x we will be popping out B, from B we will be popping out A. So next for this C, next node dot item is C B, right. So path that append will be, we'll be adding C, then it will be calling B, so we'll be checking B node dot serial which is B, which frequency is less than 1, so what we will be doing, will be appending its C to the array, correct. Now when C got appended, we'll be again traversing through B, its child is empty, but still we will be passing through, we'll be adding B, we'll be traversing B, children dot items, will be traversing through the B. This node serial will be empty because it doesn't have any what to call, it doesn't have any children, right. So this node serial will be empty only. So now still we have a path, right. C, we have C, so what we will be doing now, we have C B as a path, now we will be appending that to a array C and B. So this is how it will work. Then now this B have traversed, now we don't have already we don't have any children dot items, right. So we'll be going back. So now after B folder which has empty child, now we'll be popping out the B, then we'll be popping out C. Okay, next case comes W, it's Y, so W will be getting added, so W Y, okay. Now W will be getting added, it will be go for Y, Y has frequency 2, now nothing will be returned, path dot pop W, so WY will be not getting added because it has identical. Okay, but in case if you just assume if W has another set, okay, now another item will be traversing which is W comma child as Z, so still W would have get added, Z will go, this serial doesn't have frequency greater than 1, so now what will happen, path will get added, W will get added. Okay, next Z comma for Z children dot items it will traverse, right, which has an empty dict, but yeah we will be appending which has a default dict, right, so we will be still Z will go, so W will be getting added, now operate Z will be getting added, the child is empty, so for folder and children will not, we won't have any children dot items for Z children because it is empty, right. So now, but it has a path which is wz already, so that will also get added to the array, and it will be returning and z will be popping out. Then again when it goes back, w also will be popping out. So like this. Yeah, still even though wy and xy are identical, if it has another children, yeah, we will be still appending it to the array. So but if you see another case here, now it has yz if it was zy. Okay, so how it when we are creating a serialization, why we are doing that sort, if you remember, I have explained already. So initially for this x serialization, for x children serialization, we would have got was z y. For w serialization, if we won't do sorting, w serialization will be like y z, like this we will be getting. So when you are adding the frequency node dot serial or frequency of node dot serial plus or equals to 1, if it is same, it is easy, it will consider the same, right? So that's why if you do sorting, now what will happen, so both will have y z, so the frequency will be for y of z, frequency will be 2, right? So that's why we are doing sorting when creating the frequency table. Yeah, so now we will still, we won't add, if it is same child, still we won't be adding into the non-duplicate folders. If so, I hope I have given enough explanation how what all the things work. So the same we have solved into our solution, which um, the same which we have solved in our LeetCode solution today, yeah, which is passing all the test cases. I hope this will be you guys would have understood, and at the end we'll be returning the non-duplicate folders. Yeah, I hope this makes sense to you guys. If you have any questions or clarification, please do leave a feedback. So again the same here as well, we'll be passing through the DFS approach. So the same the time complexity will be, again you are passing through each word at each item, which is the length of, so n cross size of each word. Okay, yeah, and you are appending the path, which will be order of, which will not cost so much, we will be, because we will be basically adding at the end of the array. So yeah, so it has so many DFS traversal, BFS traversal to form a trie structure, then to form a frequency, then to form a non-duplicate folders. So we are traversing through so many DFS approach. So basically, but still it will come to the max to the 10 to the power of 6 as per their estimation which they have given. The space complexity will be 10 to the power. This is the working solution that I have created. So if you just see, we have initialized the class Trie. So why we are dictating, see why we are assigning it a dict, so that we can, is it easy to traverse through our children. So yeah, so this is how we are forming the trie structure. So we'll be traversing through the path, if the path children, if, and we will be traversing through node and path. Node and path is nothing but, if you see here, a c a b, so we'll be traversing through a, b doesn't, if b doesn't not exist, current node dot children doesn't have node as a key, then create that another trie, current node dot children node have a trie structure again. So then now we are going to the children. So like that we'll be creating all tries like how we have showed Trie in the visual representation. So then we'll be counting the frequency. Yeah, that also we explained why we are appending this to identify the folder structure. Okay, is subfolder is B, subfolder is X, so that it will be always enclosed with the brackets. So then I have told why we are doing sorting as well. Then we will be we are doing the serialization with as a string, so that it will be easy to append our frequency. So once we have updated the frequency which is greater than 1, so which means we have those duplicate folders, so that we will be calling in the operate function. Yeah, so we'll be calling initially the operate root, so their children, from the children only we are traversing every time, right? So yeah, so we will be keep on traversing the folder and the children. First we will be appending the folder. So okay, folder is nothing but the key, and the children is nothing but whatever the children further, that will be calling. Then again, if the children has the frequency greater than 1, we won't append those path, which means what are the root folders we have traversed till then, we won't update append to them. Then we'll be just returning and we'll be popping out the folder. Yeah, this works. I have just showed the visual representation of this as well, how we'll be traversing through each and how we are updating our non-duplicate folders, and at the end we'll be returning the non-duplicate folder. So this is nothing but the DFS approach time complexity. So we will be calling this 3 times. So basically what they have told, this approach in turns, so each will have characters to the length of 10, is what each path will have length of 10. So to the max it will not go to the 10 to the power of 6, so we can't calculate the approximate time complexity. So yeah, but still it's not, it will in our working example it will run even faster. But yeah, this is how the time complexity works. These are because DFS I have added the time complexity here itself. And yeah, we are storing space complexity, and for space complexity we'll have stack space complexity, as well as storing the v just for temporarily, that will have whatever the size of x to the max, and the frequency will have to store again n into all the characters, so that what is the length of each, how it, for example, if AB is, it is going, yeah, A B na will be having frequency of A B till the root, so it will also have n into size of whatever the particular path. Yeah, I hope. And the non-duplicate folders at the end will, to the max it can have no folders can be duplicate, that will also have n cross size of x. So yeah, this is how the time complexity and space complexity works. I hope I have made you guys understand how this works. This try part I haven't explained while I was explaining the solution, because I have explained in the yesterday's question clearly how to create a try, how it will look exactly. So yeah, in this I have just skipped. If you want, you can just go and watch the yesterday's solution to understand. Yeah, if you do like my video and like my explanation, please share and subscribe to your friends. That will keep me motivated to post the videos daily. Yeah, thanks for watching once again.